This is a video on using the method of washers to find the volume of a solid that's formed by revolving a region around an axis that is above the x-axis. So the question is, find the volume of the solid formed by revolving the region bounded by y equals x squared and y equals 4 around the line y equals 5. So we have a parabola and a horizontal line, and they'll give us a region, and we're going to revolve that around this horizontal line that lies 5 units above the x-axis. So first I graph it, and we can see the parabola, the horizontal line, and the line of the axis of revolution, which is y equals 5. Now we draw a cross-section. So I'm going to draw a cross-section that could be in any general area. It's going to be vertical, that draws a point on the y equals 4 line and a point on the parabola. I'm going to revolve that cross-section around the line y equals 5, and it'll get as high as way up here. So I'm going to draw that kind of mirror reflection of the cross-section. And then I'm going to connect each of these endpoints, the inner endpoints and the outer endpoints, with ovals and shade in. And what I get is a washer. So I like to draw my washer by itself, and I can see there's a smaller radius and a larger radius. And the area of the washer is pi times capital R squared minus little r squared. One of the hardest things is to figure out what little r and capital R is. Well, the small radius is going to be the distance from the line y equals 5 to the line y equals 4. And we can see that distance is 1, because that's all the way up to 5, and then take away all of this 4, and you get 5 minus 4 is 1. So now for the larger radius, that's going to be the distance from y equals 5 to y equals x squared. And we can see the distance from y equals 5 all the way to the x-axis is 5. But we need to take away this distance from the parabola to the x-axis, and that will be x squared. So we get r equals 5 minus x squared for our larger radius. So now we plug that into the area formula, and we get the area is pi times the larger radius squared minus the small radius squared. And then the volume will be the integral of the area. So it's pi times the integral. We're going to go -2 to 2 because that's where the two curves, or the parabola and the lines, intersect, of the larger radius squared minus the smaller radius squared dx. I worked that out on my calculator, and what I got was 177.25 or so. And we're finished with the problem.